Hello and welcome to today's CDCT live session. My name is Jason Rader and I'll be your host today as we continue our IoT conversation. Today focusing on IoT at the edge. With me today we have two rock stars that are going to help me get through this conversation. We have John O'Shaughnessy, who is an architect and senior consultant, and we have Andrew Nelson, who is a principal architect with us here at CDCT. Welcome, gentlemen.
Good morning. Nice to see you too, virtually.
Virtually, yes. As we talked about, that commute is not so brutal. So let's kick it off. We'd like to kind of catch everybody up what we're talking about. When we're talking about IoT at the edge, what are we referring to here? Andy, I'll let you take that one.
So we're talking about devices and communication and infrastructure that happens to be not in a data center is probably the best way of saying it. It could be in an office building. It could be in a tin shack in the middle of nowhere. It could be in a trailer at a construction site, and it could be the middle of the Gulf of Mexico at an oil rig, but not in a data center, not in the cloud.
Got it. And we're talking about that compute happening at the edge, and we'll talk about the different scenarios that kind of goes on related to that. John, do you have anything you want to add to kind of highlight?
No, I think the key thing as we talk about compute in IoT is we're just getting away from maybe it's a camera, maybe it's a doorbell sensor, and it's actually doing some work on that data out at the edge, as opposed to relying on a network to pull it all back for all the processing to be done in a data center.
Well, John brings up a good point too. There's an interesting hybrid approach to this where we're starting to see cameras and sensors with compute embedded, with more compute embedded than they have traditionally, for exactly that reason. Is instead of discrete compute, we're starting to see cameras with a little bit more horsepower so that we can do compute there. That's an interesting conversation we can pull on later.
Well, let's do it now. Let's don't hold back. So why would we need more compute than we would traditionally if we were talking about cameras or sensors at the edge?
Well, it has to do with the kind of the richness and the data value that comes out of the data that we're collecting. So everybody dabbled in IoT, reading a thermometer or a temperature gauge or a door lock, if you will, whether a door is open or not. None of that takes any processing, right? It's static data that we pull back maybe every 15, 20 minutes, an hour. It's not super interesting. But now we're starting to see more detailed camera video data, facial recognition, heat map tracking, people tracking. So a lot of retailers are doing people tracking, which, whether you like that or not, it's happening. That data starts to become big and thick and needs to be processed either locally or isn't efficient moving over a WAN or both. And so we need to be able to clean up the data, process the data, analyze the data, and potentially display the data to people that are local, like a store manager or a security guard or something like that. And to process that in the cloud, to send all that video data to the cloud and then pull it all back, doesn't always make a whole lot of sense. So we're starting to see that data locality, data gravity issues. I'm throwing out as many buzzwords as I can fit in. Yeah. Bingo. But it all means the same thing. It means the data needs to stay local and be processed local.
And the interesting thing to go along with that is those environments where you can't have good network connection. Maybe you're on a speeding train, et cetera, and yet you do need to show that data to the folks on the train, and you don't have the ability to send it off to a data center and then pull it back. So again, you're seeing all sorts of reasons to pull this compute closer to the edge devices themselves.
We had a conversation previously about police cars, and it's a very interesting conversation when we start talking about self-driving vehicles. Self-driving vehicles are the ultimate IoT device that fits exactly what John just said. Is I've got multiple cameras, LiDAR, motion sensors, and I have to be making real-time, low-latency decisions so that I don't kill people. And there's no way you're sending that data off board and back again in a reasonable amount of time. And to John's point, sometimes they may have great 5G, 4G, 5G connectivity, and sometimes they might be in a rural area. They have to be able to make decisions on board and not rely on that connectivity. We see that with a lot of our emergency vehicles now, where they've got a whole bunch of tech in the car, and if they can't use that tech or process the data or record the data, I mean, if you ever look in the back of a police car, they've got a data center in the back of a police car now for most modern workforces, for all these reasons.
Got you. So with that being said, I think you kind of broached a topic that's probably worth digging around in. So like back to self-driving cars, for example, like when I think about those, I think about, kind of the autonomy of the vehicle, but you kind of brought up a point, is that some of the information and telemetry sent back somewhere else. I mean, there's probably going to be, if not already, a place where the cars are talking to each other via some other mechanism, as well as, coordinating a fleet of cars over the course of, states or countries, if you will. Are we at that particular level? I mean, I guess what it is as people embrace this type of capability and we start processing at the edge, give me some use cases where, more use cases related to how we're doing stuff like this.
I mean, a good one is a case study that we have on insight.com is to use your autonomous driving and cars communicating to each other. We've got a case study where we actually increased warehouse productivity by tying forklifts together. And what's interesting, to put it in a perspective that most people are used to, the faster you drive on the freeway, the more distance you have to put between you and the next car. Well, yep. That's not because of the car. That's because of our latency as a human being to figure out, I have to pump the brakes, and how fast do I have to brake? If I've got 2 or 3 cars that are talking to each other and the car up front says, hey, I'm braking, the car behind can brake at the exact same time, and it starts to work a lot more like an electronic train. In a warehouse, it's the same idea. As I can route forklifts much closer together, I can move them quicker on the floor. If they're talking to each other and they're working like one unit, I don't have to have that buffer that we would have to have for humans. So that immediately increases productivity and probably safety. Like if you follow most of the news, most of the issues with the self-driving cars have very little to do with the self-driving cars and everything to do with the layer 8 wetware that's driving the other cars on the road.
Yeah, I think that's the holy grail, is when you get these things communicating to one another, you don't have to have supreme intelligence in the one thing. It's everything playing together in a hive mind, saying, I am going to try to exit on that next exit that's just a quarter mile up. So all the rest of you cars, back off.
Yeah. Well, and this is more interesting, I think, like in the whole self-driving semi-truck industry that's trying to take off. I had worked in a previous part of my career at Insight with a customer that was doing the onboard telemetry. So that's super important for semi-truck drivers to be able to have that electronic log. And we've actually seen cases where it's actually helped the drivers in court to have that telemetry and such. But the trucking companies also use it to estimate ETA and all that stuff that we see on Amazon.com and shipping sites. That starts to tie into the same conversation, because if I've got a self-driving semi-truck that's got that same telemetry, that becomes a much more interesting efficiency play, as I can route my semi-trucks around accidents quicker. I can estimate JIT shipping kind of ETAs, if you will, in a much more AI ML way than doing it manually.
And so you guys kind of bring up an interesting thought that I know we brought up before when we were talking about this. It seems like, we were on this kind of thin client paradigm, if you will, and now we're back to this thick client, maybe with an IoT perspective.
Yeah, it depends. I mean, go ahead, John.
The accordion world of IT, out and in, out and in. And that's absolutely right. And we've talked previously about, does a retail store, for example, go to a completely thin thing where all you're looking at is an iPad and nothing else is at the store? That may sound great.
Yeah, kind of the square model, right, John? Yeah,
absolutely. Or do you have more of that intelligence in the store because you're trying to do more with that data? And again, I think we're kind of shifting back to that. And Andrew, I think you've got some more details on some of those.
Well, it's a pendulum, absolutely, and it's not so much that there's specific right and wrong answers. It's just super interesting to find the companies that are mining that extra intelligence of the data are really getting an unfair advantage in the marketplace right now. So we're starting to see that the retailers and the companies that have figured out how to do some of this, I mean, I'll use the word IoT because that's what we're talking about, but extending the reach of technology into their architecture, they get more data and they make better decisions and they make faster decisions. And all of that has some form of ROI. Now, the question is exactly what you just were digging at, John. What's the ROI of that data? If I've got to go spend a ton of money on sensors and infrastructure out at a retail store, and I'm going to use a cliche, it's the dollar store where my margins are razor thin, that might be a little bit of a stretch. But if I've got a Apple store or a Nordstrom's location where I've got a different profile, maybe some of that intelligence is more, or use the Costco example. Costco's notorious for proactively moving product around their floor to drive different patterns of people. And they have done it in a manual way in the past by manual engineering. But what happens if they've got heat map tracking in the store and they can figure out when they move the Costco bacon to a different corner, profits go up 2%. I mean, that's the kind of thing we're seeing in the retail industry, and that's giving them an unfair advantage, and that can have tangible ROI. Don't do it for the sake of, I just want to see everything in the store.
No, and that's interesting because, we've worked with folks before to get to more of that thin model like you guys were talking about. Some of that has to deal with complexity of implementation, security comes into play, compliance comes into play with those things. And as the pendulum switches back, there's obviously an enticement to do more processing at the edge because of this. And like you said, mobile data centers or data centers in every vehicle potentially or every store. But that also brings up the concept of security. Now, we've talked about data before. Now we're talking about processing and that data there. Security becomes an interesting thing because now with mobile data center, we have like data center level security requirements that we've got out there as well.
Yeah, potentially. It depends on what kind of data you have, right?
Yeah.
We've got hospitals and clinics that have HIPAA related data potentially in these new IoT environments. One of the neat trends in the hospital system is doing Bluetooth tracking or RFID tracking of components like a ultrasound machine or a radiology equipment, and that's very much IoT. To have a little sensor on a portable cart with some gear on it and be able to figure out where it is. The extension to that is some building badges now have RFID built into them, and not low power but high power RFID. So I actually track where the nurses are at the floor at any given time and page, instead of paging everyone, page specific nurses. And our sister organization, Digital Innovation, has some case studies that they've done with different hospital systems where they're starting to put some of that intelligence into their, both the equipment and the people scheduling. But that's all HIPAA data, right? To some degree, as soon as I've got cameras in the hallways, as soon as I'm tracking equipment coming and going from a surgical theater, now I've got all the HIPAA regs and HIPAA security issues. And let's not even think about hacking the radiology machines or hacking the surgery center while we're in the middle of surgery.
We're also getting
ransomware there.
Well, yeah. No, we're also getting on like the front end of, a lot of the protections in the EU and in other areas like the newest CCPA recs that are out have a lot of protections for PII or employee related protections as well. I mean, you just talked about a good aspect of knowing where the nurses are. There's also that bad aspect of knowing where the nurses are. Hey, you guys were all on break at the same time, those kinds of things. Not that I don't think they deserve breaks. I just am saying how you can misuse information just as much as you can use it. And from a privacy, securities is several things, right? But I think, when we start talking about all the privacy implications, whenever we embrace technology the way that we do, I think that there's that awesome way that we're leveraging the best parts of it. And then all of a sudden there's the security aspect that either people exploit, the bad guys exploit, or the boss man exploits or whatever, that we have to start putting those protections in place for. And that this makes things, I think you'd use the term islands of security before related to that, where you got to kind of think about them that way.
Yeah, well, and one of the conversations John and I have had offline is that, this is new for IT. And yeah, to some degree, the terminology we're using and the reach of this technology is new, but the security paradigms, the infrastructure, I mean, I come from a utility background. We've talked about something called SCADA for years, which SCADA really is IoT. Anybody that's worked in a warehouse or a manufacturing facility has had an industrial equipment that does the same kind of IoT stuff. And on the security front, John, the group that you're in at CDCT makes a living mapping security and compliance issues to architectures. This is no different. It's establishing, what are the rules and regulations? How do they map to tools and policies? And then do we protect all of those remote locations exactly the same? Do I have the same security controls in the data center that I have out at the edge? Probably not, but I might have some of the same tooling and monitoring. And I mean, that's something that you guys do a lot of, John.
Yeah, I mean, it's as you say, Andrew, it's getting back to understanding what the problem is that a client's trying to solve figuring out that yes, some of these tools may be somewhat new or somewhat relabeled, but the policy concerns are the same. The decisions you have to make about what you're going to do with the data are the same. But again, I think as each of these things becomes more and more powerful, the risks are greater. And I always joked about a previous client that had, some Cat5 Ethernet running down a hallway, stapled up in the corner. It's like, well, really, what is at the far end of that? And I come to learn it was a camera. One little old camera, probably not a big deal. But if at the same level, that exposed data is now, full of client information, full of patient information, because no one bothered to realize that that piece of infrastructure was now carrying much more sensitive data, that becomes a concern. So as these technologies change, as we enhance the smarts out at the edge, we need to enhance all of the pieces supporting those things.
Well, and it's not like, I mean, it's fairly common knowledge that one of our large retailers in Minnesota was hacked through an HVAC system in the same way, right? A management interface on an HVAC system. So these islands of security, that I'm talking about, there's different techniques that we've used forever, DMZs and isolation and firewalling and packet inspection and you name it. None of that is necessarily new, but the form factors are new. So that's the other kind of punchline here, Jason, is all of this technology we're talking about, the overall architecture might be the same, but a lot of the devices, form factor, and some of the players in that space are totally new. Like, I mean, if Jason, you've got a deep background in security. To do traditional packet inspection is very expensive, right? Big gear, very expensive hardware. There's no way that scales to thousands of sites, to thousands of devices. So how do we embed some of that functionality into smaller devices in a software stack or a hardware stack? And this is where like that hardware root of trust buzzword that everybody talks about comes into play, is how do I trust the devices out in the field, and how do I embed some security tooling? And this isn't new. We've been doing this with laptops and tablets and such, but it's getting even smaller when I have a camera with barely an ARM chip on it. How do I secure that, for example?
I think that's a great point. You bring up two things. One, that we don't have to go get any alien technology to be able to secure this stuff, right? It's still, there's governance models, there's data types, there's security controls that we can put into place. We just got to make sure that we understand where the data actually is, where it's being collected, and those types of things. And I think that's kind of, I was going to ask John, does that make it harder from we're good at mapping workloads and those kinds of things. Does IoT make it kind of harder to help organizations understand what constitutes the entire workload?
It absolutely does. I mean, one of my favorite stories is a data center move, and the client figured out everything they felt was important. And this was in the old days, so it was a physical move. So you load up the truck, you go across town, you set it up, you do your smoke test. Everything seems great. About 2 days later, they realized that their quantities in one of their databases was low because it was tied to a remote sensor that weighed trucks coming in to drop off salt. And that was never reconnected. So they were losing all of that data because they hadn't taken their analysis out far enough to understand all of the sensors that were needing to be tied together. So yeah, absolutely. It makes this concept of dependency mapping between workloads and their underlying infrastructure even more complicated.
Well, John brings up the other kind of corollary to this too, is the operational, what the term that everybody uses now is OT. It's the operational technology side of the house. But we're talking about security, we're talking about infrastructure. What we're skipping over is if I have thousands of sensors at hundreds of sites, somebody's got to manage that. I don't have to maybe, but somebody or something has to manage that. And it has a security bent, right? How do we upgrade firmware? We've seen multiple hacks that turn devices and sensors into Trojans. Well, I have to be able to upgrade the firmware in a timely fashion. I have to be able to check the health of a lot of those sensors. Like John brings up a great point about a weight scale for a salt processor. I've got retailers that have sensors in the parking lot that pick up the trucks as they come in, so they get redirected to the right loading docks, and that slows them down they can't do that kind of thing. It has productivity issues. So from an operational perspective, how do I manage all of that? I mean, if it's an oil rig in the middle of the Gulf of Mexico, how do I manage all of that? How do I monitor all of that? And it's, we don't monitor it and manage it the same way we'd manage data center resources. This is that old pets versus cattle analogy we use all the time. But I still have to keep track of them. And I still have to make sure that they haven't gone rogue. Like your point, John, I mean, how long did it take them to figure out that they were missing that? Days, weeks, months?
It was a couple days to figure it out, and then another couple days to get it going again.
Yeah.
Yeah, and I think, you know, that's the other thing. I think as we're talking about all of these capabilities, you know, a lot of the things that first of all, there's that, I always think security kind of comes, and just in general, there's that can we connect it kind of thing that happens. Then there's the can we secure it kind of thing that happens. So there's always, can we do it? Okay, now how do we secure those things? A lot of the aspects, especially when we're embracing new, it's not necessarily new technology, it's new ways that we're using technology in some cases, but that connectivity aspect of now we've got all of these things that are connected, being really sure that the things that are getting connected into your environment are valid devices and are trusted devices is another aspect that a lot of people, you know, think about after they made sure that the connectivity was there.
Well, and you bring up a really cool point that a bunch of our vendor partners are chasing in different ways. There's a fair amount of AI being built into some of our endpoint security, where it's detecting traffic patterns. It's more than just looking at a MAC address. It's more than just looking at an SNMP string. It's actually profiling how these sensors talk, how they join the network, and then putting in some intelligence to figure out should they be on the network. Very similar to the old 802.1x authentication that we've done for wireless, but on steroids. So not only is it should you be on this wireless network, but you should probably only be talking to this one aggregation layer. And all of a sudden you're trying to talk out to the internet, and I'm going to black hole you and alert somebody to say, go look at it. And all of that is, I mean, you can't do that with people, is kind of the point I was making before. So they're building a lot of this into their NAC intelligence or to their wireless edge or wired edge. And it's that part is new. That I'll give you, John, is that level of intelligence at the edge is very new in our industry, because you just can't do it with people. If you do it with people, it's not going to work.
Yeah, it's taking that whole mindset of islands of data and islands of security, and this blob can talk to this blob, but not every other blob, as opposed to the old world of, hey, we're building a perimeter and we've got this lovely moat and we are comfortable 100% with everything inside talking to everything else, but we're keeping the outside stuff out. That model just does not work anymore.
Really? You mean with everybody working from home, that model doesn't work anymore?
Isn't it amazing? You might almost think of it as spores on the outside of a virus cell.
Well, and effectively, I mean, I'm joking, but I'm not. I mean, we're effectively IoT employees now for most companies. That it's a lot of the same security issues and a lot of the same problems. And I mean, and my network at my house, and I know yours, Jason, has a whole bunch of devices on it. It's an IoT security problem in a totally different way.
Yeah, we can see John's in the background.
Yes, I've got the whole lab.
But I think that, you know, you guys just brought up the point, and, you know, that's these epiphanies that we have during the conversation. You know, a lot of the times when I'm thinking about security and I'm trying to make people understand, you know, we're trying to make it easier, right? We kind of get super focused on the data. You know, okay, let's figure out what data is being created. Let's figure out in transit where it's being stored. Let's secure that data there. But if we bypass thinking about the hardware that it's actually being processed by, we're missing a giant gap. And this exacerbates that because it's now outside of this place that traditionally we had the moat around, right?
Right. Yeah. Yeah. I mean, this stuff is by nature, it's going to be out in the hallways. People are going to walk by it. You're not going to be able to prevent someone from messing with a camera the same way you're hopefully preventing someone from unscrewing your 2U server in a rack somewhere in a data center.
Yeah. Yeah. There's a great James Bond movie that where he just walks up to the security camera before he goes in front of it and unplugs it, and then he just walks around it. Those kinds of, when you were talking about the Cat5 going down the hallway, those are the kinds of things. But that stuff matters so much more now than it did, based on this additional processing that's happening at the edge, because now this is enriched data that's potentially coming through, as opposed to just the camera, the raw data, you know what I'm saying? And now it gets into that PII or those other kind of security regs that we're dealing with.
Well, and this is where things like those T4 chips and hardware root of trust become important.
Yep.
We're seeing a lot of our kind of more mainstream OEM vendors coming up with computing devices and hardware that the minute it's tampered with, kind of crypto shreds itself, right?
Yeah.
Locks itself up, isn't repurposable. So if somebody does walk up to a sensor or walk up to a computing device that may have some PII data on it, awesome. The minute they walk off with it, it doesn't work. And similar to the technology we've had on our laptops for a bit, where we can lock down a laptop and have the drives encrypted, but it's a little bit more lower level because I can't have a user typing a password. It's built into a certificate or the way that they're talking on the network. And then the minute that device is tampered with, it locks itself up. And that's becoming table stakes for a lot of these edge computing devices for exactly what you say. So Bond can go steal the camera, but he can't get any of the data off it.
And so, guys, we got a lot deeper than we ever planned on getting into this conversation. I think that to not scare off the faint at heart, what are some tips that we should give folks as far as, if they're, I doubt that a lot of them are really heavy into this without thinking about it, but folks that are thinking about leveraging, getting that business edge that happens when you're leveraging IoT at the edge and those kinds of things. What are some tips that we would have? I'll let you guys go in turn. John, why don't you kick it off?
Again, I think the key thing is to think about what it is that you're trying to do. What are your goals? What are your requirements? Do that planning. Do this all at a whiteboard. Figure it out before you race out, buy product, start plugging it in. Because it's a whole lot easier to design the security and design the operational efficiencies in ahead of time.
Well, and I'll take and run with that because everything you do with IoT is going to double or triple before you know it. So one of the things we're hearing from most of our IoT-like partners is customers go through the planning exercise. They do exactly what John said, and then 2 years in, they're like 3 times bigger than they need to because it definitely expands. Well, it works. You see ROI, and then it should be easy to add another 100 sensors, and whoa, that breaks a lot of stuff. And not to sound like a sales pitch, but we know how to do a lot of this. We've got expertise, traditional expertise in the SCADA markets. We've got infrastructure expertise, security expertise, and our digital innovation brethren, which is a sister organization, Insight, are already doing this with customers. And the challenge is both in the initial implementation and then scaling and then operating. And we kind of danced around all of those topics. Nobody's got this totally figured out, but you want to leverage people that have done some or all of it before you embark on it. I mean, I always ask for advice and then do it myself. So go figure.
No, I think that's a great point. I mean, and we want to empower folks to, do what they do. But I do think that in some cases, on my 5th trip to Home Depot, and they recognize me. I'm like, yeah, why don't you just tell me how to do this? Or maybe tell me who I can get to do it for me. This is, these types of things are expensive. And they can really affect, a misstep with some type of technology like this can turn the whole organization off, or, delay that leverage that you could get out of using the technology for years down the road. So I think it is one of those things where if you want to get a partner, a trusted partner in there to help you from the design, from the implementation, from the roadmap of where you want to go capability wise, it is a good idea to do those things.
I mean, you bring up a great point, Jason, is that this stuff isn't going to get refreshed every 3 to 5 years like traditional IT gear. Right. And you're going to be stuck with it hopefully for 5 to 10 years in the field or longer. And so a poor choice of technology means that you're going to be saddled with that for a long time. And there's going to be poor choices for technology. I mean,
sure,
we've worked in this industry a long time to know, but those ripple effects are bigger on budget and on perception and all that kind of stuff.
Oh, well said. Well, gentlemen, that has been a fantastic session. We could probably keep talking about this, but we'll wrap up here. Thanks for everybody out there who's been listening with us, in our journey through IoT, talking about the compute, talking about the data, talking about the security aspects of it, talking about the edge capabilities here. I think my guests, Andrew and John, you guys rock today. And if you'd like to know more about what we do here at Insight CDCT, please visit us at insightcdct.com. Thanks, gentlemen. You're awesome.